Dear student, now we start with the new topic, alternating currents. In the previous topic, electromagnetic induction, we studied about what is electromagnetic induction, self-inductance and mutual inductance, AC generator, etc. And its a continuous part is alternating current. So, in the previous topic, we know about the formula for alternating voltage and current. We derived that formula. So, alternating voltage is given by the equation V is equal to V naught sin omega t, and current is also given by the formula I is equal to I naught sin omega t. Now, if you look into these two equations, then you feel that you know this type of formula even in first PU, simple harmonic motion. So, what is the equation for simple harmonic motion? Y is equal to A sin omega t. Like that, alternating voltage V is equal to V naught sin omega t and I is equal to I naught sin omega t. It is voltage and it is current. Now, it is not simple harmonic motion, it is simple harmonic variation, because there is no particle executing as such. It is the voltage and current changing, which is similar to simple harmonic. Therefore, it is known as simple harmonic variation. Okay. Now, we plot the graph of this voltage and current. The graph is similar to graph of SHM. So, this is time along x axis and we take voltage along y axis. Now, here time is we take it as t by 4, where t is the time period, and t by 2, 3t by 4, and this is t, time period. So, you know, even in first PU, we have got this type of graph for SHM. Now, I want to plot current, I is equal to I naught sin omega t. Look here, it is sin omega t and here also it is sin omega t, therefore, graph must be of same type. But in AC, in this topic, voltage is always represented by continuous line, thick line, continuous line, but current is generally represented by line like this. It is not a continuous line, it must be a broken line like this. It is just to get idea which one is voltage and which one is current. So, this is the graph of current. So, current is represented by broken line and voltage is represented by continuous line. So, this is representing voltage and it is the graph of current. Now, both have the same phase angle omega t, therefore, graph is alike for both. Now, this is plus V naught and here minus V naught. Now, look here, what is this V naught? I said in the beginning, SHM is represented by Y is equal to A sin omega t. What is this A in this formula or in this equation? A is nothing but amplitude, that already know. We studied in SHM, amplitude. So, here it is amplitude, like that here it is V naught. Therefore, we can say it is the amplitude of voltage. Then what is I naught? Amplitude of current. So, this is plus V naught and here this is plus I naught and this is minus I naught. So, this is the graph of both voltage and current. Now we discuss some of the important terms associated with the AC, general terms. Even in SHM, we have got a number of terms associated with SHM like time period, frequency, phase angle, like that. So here also same. But what is the difference between the definition of SHM and AC? If it is SHM, simple harmonic motion, where particles or particle is executing SHM, but here there is no particle, voltage and current, therefore don't say oscillation. Instead of that, it is better to say variation, cycle of variation. Now we start with the first term, that is time period of AC. Period of AC, alternating current. What is the period of AC? Now it is known as a positive of cycle because the value of both voltage and current positive. Then what about this negative of cycle? So positive of cycle and negative of cycle, it is together known as one cycle of variation. It is known as one cycle of variation. If it is SHM, it is known as one oscillation. But it is not oscillation here because there is no body or particle, it is voltage, therefore it is known as the cycle of variation. What is the meaning of cycle of variation? Positive of cycle plus negative of cycle together known as one cycle of variation. So what is the period of AC? Period of AC is the time taken by the AC to complete one cycle of variation. You can expect for 1 mark. So you have to write correct answer. What is the correct answer? Period of AC is the time taken by the AC to complete one cycle of variation. Don't write one cycle of oscillation. No. Next one is, whenever you have got a term period, what is the reciprocal of period? Frequency. Therefore, second term is known as frequency of AC. Frequency of AC. Second term. Frequency of AC is the number of cycles of AC completed in 1 second. This is 1 cycle. How many such cycles completed in 1 second? Known as frequency of AC. And frequency of AC symbol is F, which is always equal to reciprocal of time period. This is already known. I am not going to explain it again and again. Even in first PU, you have got this relation. Frequency of SHM is equal to 1 by T, where T is the time period. And frequency always expressed in hertz. Its SI unit is hertz, which is also known as CPS, cycles per second. And time period is in second. Frequency, its SI unit is hertz or CPS, cycles per second. And now third term about AC is instantaneous value of AC. Third point. Instantaneous value. What is this instantaneous value of AC? It is written as V or I. Its symbol is V or I. Look here, instantaneous value means it is the value of the AC at the given time. Now, I am taking separate graph to explain. Let us say it is voltage, voltage of AC. Actually, it is the plot of what? It is the plot of voltage with the time. So, you take any time interval here. For the particular time, you have got a particular voltage. For the particular time, you have got a particular value of voltage. Or for the particular time, you have got a current. But here I am plotting only voltage. Same argument holds good for current also. So, this is the graph of voltages at different time intervals. At the particular time, let us say time is T1, you have got a particular voltage. Let us say V1. What is this instantaneous value? Or you take another time, let us say time is T2. Corresponding voltage is V2. V1 is the instantaneous value at the time t1, V2 is the instantaneous value at the time t2. So, actually it is the graph of instantaneous values. Like that current also, current. Therefore, instantaneous value of AC is the value of voltage or current at the given time. As time changes, both V and I, both of them are changing, known as instantaneous value. And look at this equation. Here V represents instantaneous voltage and I represents instantaneous current. This is instantaneous voltage and it is instantaneous current. Okay. Next one, mean value of AC over the full cycle. Very important one. Mean value or average value of AC over a cycle. Mean value of AC over a cycle. So, see this one carefully. It is a, here I am clearly telling that over a cycle. Okay. Now, from this graph it is very clear, with the time voltage changes or current also changes, and whenever value changes we have got different values, it is better to find out average. For example, in annual exam, if you get different marks in different subjects, then generally we find out average mark. We add all the marks of the subject divided by number of subjects. Think that you got same mark in all the subjects. Let us say you got 95 in all the subjects. What is your average? Average is also 95, because in all the subjects 95, average is also 95. No need of finding. But in different subjects, if you got different marks, then we find out average. Like that, here voltage changes with the time, current changes with the time. Therefore, we try to find out what is the average value of AC over the complete cycle. Now, what is the answer? The answer is 0. Average value of AC or mean value of AC over the complete cycle is always equal to 0. Now, what is the reason for 0? Answer is very simple. For every positive value here, there is a corresponding negative value, and when you add them, that sum becomes 0. For example, here it is a plus 1 volt. Here we have got a minus 1 volt, because graph is symmetry. Plus 1 volt, minus 1 volt, they cancel each other. Or plus 2 volts, let us say here it is minus 2 volts. When you add, it is 0, plus V naught, here it is minus V naught, again answer is 0. Therefore, for every positive value here, we have got a corresponding negative value, and whenever we add them over the complete cycle, answer is 0. It is a 1 mark question in annual exam. Be careful, you have to read the question twice. Why? I will tell later. What is the question? What is the mean value of AC over the complete cycle or over the full cycle? Then only you write answer as 0. Okay. Now, somehow I want to find out a mean value, because it changes with the time. So, it is better to have a average value. If I take full cycle, answer is 0. So, now we try to find out average value of AC only for half cycle. If you take only half cycle, let us say this cycle I am taking, positive cycle. If you add all the voltages here, because every point is the instantaneous value, if you add all the voltages, then the answer is non-zero, because there is no negative value. This is neglected. Negative of cycle is neglected. So, we take only positive of cycle and we find out average. Then we get the answer, that is known as mean value of AC. And we never say it is mean value of AC over half cycle. No, we simply say mean value of AC. So, look at the difference. How to tell this one? Mean value of AC over the full cycle. What is the next one? Mean value of AC. Mean value of AC means it is only for half cycle over the time period T by 2, not full. But even though it is taken for a half cycle, we never say it is the mean value of AC over half cycle. No. What we say? Mean value of AC. So now we consider mean value of AC or average value of AC. Only half cycle we take. Now, here in this graph, every point is a mean value, but to make it clear, I am taking only some of the points. Let us say here it is V1, instantaneous value is V1, this is V2, it is V0, it is V3, like that. So, how to calculate mean value of AC? Mean value of AC is calculated, you have to add all the voltages in the positive cycle, that is V1 plus V2 plus V0 plus V3 and so on, up to what? Half cycle divided by time interval. What is the time interval? T by 2. T by 2. And how to get this sum? It is only by the method of integration. Of course, it is not required. So, if you add the voltages, it is by the method of integration. Therefore, this numerator is by the method of integration over time interval 0 to T by 2 divided by time taken T by 2. And if you simplify that one, that answer is, it is 2 by pi into V0. So, you have to remember this equation. Again, one more question. Write the expression for mean value of AC. It is 2 by pi into V0, where V0 is the maximum value of AC in the positive cycle or even in the negative cycle. Similarly, for current, IM, mean value of AC, is equal to 2 by pi into I0. So, it is the equation for current, mean value of current. Now, how to define it? How to define mean value of AC? So, you have to tell this definition. You take this formula as the definition. So, how to define? Mean value of AC is defined as the ratio of sum of the instantaneous voltage, sum of what? Instantaneous voltage divided by half of the time period, divided by what? Half of the time period, or mean value of AC is defined as average of the instantaneous value only for half cycle. Average of what? Instantaneous value only for half cycle. Next, amplitude of AC. Amplitude of AC. Amplitude of AC. Symbolically, it is V0 and I0. Okay. This is very simple. Amplitude of AC, it is nothing but maximum value of AC attained in either half cycle. It may be positive cycle or negative cycle. Amplitude of AC is also known as peak value of AC. Peak value. So, In most of the case now onwards we use the word peak value of AC, but in entrance exam especially they use the word amplitude of AC. Do not get confused, they are one and same. Voltage is represented as by the symbol V naught, current is represented as I naught. It is the maximum value of voltage or current in either half cycle, it may be positive or negative. Next one is RMS value of AC. So, RMS value of AC, very important value. Now, so this is the graph of voltage, and whatever the explanation for voltage holds good for current also. I want to define RMS value. So, somehow I want to find out average value over the complete cycle. But earlier I said, if you try to find out the average value over the complete cycle, what is the answer? 0. The reason is, for every positive value here there is a corresponding negative value. When you add them, answer becomes 0. So, how to overcome this problem? We can solve this one by squaring the instantaneous value. Now, what is the significant part here? We know whenever you square, even the number is negative, square is positive. For example, minus 3 whole square, what is the answer? 9. Minus 4 whole square, answer is 16, it becomes positive. Therefore, you take negative cycle. If you take negative cycle, it has got a negative instantaneous value, you square it. If you square it, it becomes positive. Then it can be added. So, answer never be 0. So, what we do, we try to find out the average value over the complete cycle by squaring the instantaneous value. Now, as usual, let us say we select some of the points here like V1. This is V2, V0, V3, V4, like that. Now, for every value, we get the square. So, now, it is like this, V1, I am taking its square value, V1 square, plus V2, instantaneous value is V2, I am getting its square, V2 square, plus V0 square, plus V3 square, plus V4 square, etc. over the complete cycle, full cycle, up to the time t, divided by t. Now, what is this? Look at this. Is it not the average value of the squares of the instantaneous value over the complete cycle? It is the average value of what? Average value of squares of instantaneous value over the complete cycle, full cycle. Now, to compensate, because we are squaring, so to compensate that we take square root. Then we get the value that is known as VRMS. So, what is VRMS? RMS value of AC. RMS value of AC is the square root of the average of the squares of the instantaneous value over the complete cycle, full cycle. That is the definition. And again, how to get this sum of the squares? Can we select these particular values V1, V2, V0, V3, V4? These are all selected values. Every point is an instantaneous value. Therefore, it is only by the method of integration. This numerator can be solved by the method of integration, that is not required. But by the method of integration, if you solve, then the last answer is, last step, it is V0 by root 2. So, V RMS is equal to V0 by root 2. What is V0? It is amplitude of the AC. Like that, current is given by I RMS is equal to I0 by root. So, you can expect this one for 2 marks. Define RMS value of AC, write the expression for it. So, definition carries 1 mark and equation, writing the equation carries 1 mark, very simple. But while defining, be careful. How to define RMS value of AC? RMS value of AC is defined as the square root of the mean of the squares of the instantaneous value taken over the full cycle. This is the equation. And in exam or even in entrance exam, you can expect one more question. Instead of asking write the equation for mean value, write the equation for RMS value, they ask one more question, write the relation between RMS value and mean value. RMS value and mean value, that I wrote already. What is the formula for mean value? So, how to get it? Very simple. What is the equation for mean value? It is 2 by pi into V0, or V0 is equal to, simplify this one, it is pi into Vm by 2. V0 is equal to pi into Vm by 2. Okay. Now, Vrms is equal to V0. Instead of V0, you write this value. It is pi into Vm divided by 2 root 2. So, it is a very, very important equation. It is the relation between RMS value and mean value of AC. Same type of equation for current also. Now, see, in all these discussion, frequency, time period, instantaneous value, amplitude, mean value over the full cycle, mean value of the AC, RMS value, definitely you can expect questions carrying 1 or 2 marks, and from the point of competitive exam, this is a important equation. Yes. Now, we discuss AC applied to the different components. We study 3 components in separately, that is the resistor, AC applied to the resistor, AC applied to the pure inductor, AC applied to the pure capacitor. So, very basic. If you know this discussion and if you know the formula, conditions, etc., then the further study in the same topic becomes much easier. So, AC applied to the pure resistance, AC applied to the pure resistance. See, AC applied to the pure resistance means it has got only resistance and all other values are 0. And in the question paper, the question may be like this: AC applied to the resistor. For that and this, answer is same. Now, we take simple circuit. It is the resistance R connected to the AC source. It is the symbol for AC source, see, which produces sinusoidal voltage. Don't put plus minus. If you put plus minus, it is wrong, because it is alternating, polarity continuously changes. Therefore, if you write plus minus, for that you may lose 1 mark. So, it is the wrong marking representation. So, do not write plus minus. And here, in all our discussion, we start with the voltage, we derive the formula for current. Means voltage is the first thing, first physical quantity, followed by current. Voltage produces the current, but current is not producing voltage. That is why here we have got a standard equation for voltage. V is equal to V naught sin omega t. Definitely, when you connect resistance to the AC source, you have got a current. Current is I. Again, I. What is this I? Instantaneous current. Look at the symbol I. Don't put arrow mark. If you put arrow mark again, it is wrong. So, by mistake, for the AC circuit, if you put arrow mark, there itself you are losing 1 mark. So, it is the current I. Now, we know according to Ohm's law, current is given by the equation I is equal to, it is V by R, very simple formula. But what is V? Instantaneous voltage. Therefore, it is V naught sin omega t by R. Now, you separate V naught by R. It is the maximum voltage divided by resistance. Maximum or highest voltage by resistance, that becomes highest current. Therefore, this formula can be written as I is equal to I naught into sin omega t. This is the equation for current. Let us say it is the equation for voltage, equation 1, it is equation 2, where I naught is equal to V naught by R. Very clear. Is it not amplitude of the current? It is amplitude of the current, or known as peak value of the current. Peak current. Now, look at the equation for voltage and current. They are alike, means the equation for voltage, look at this phase angle sin omega t. In the current, what is the phase angle? Sin omega t. Means both voltage and current, both of them are changing together. Means as omega t value increases, the same value comes here, sin omega t. So, if voltage is increasing, current is also increasing. If voltage becomes 0, current becomes 0. When voltage becomes negative, current becomes negative. So, both of them are varying together. Hence, we say current and voltage are in phase. Current and voltage are in phase. So, from 1 and 2. We can say V and I are in phase. Or what is the phase difference between them? Phase difference. Let us say phase difference is phi is equal to, what is the phase angle here? Omega t. What is the phase angle here? Omega t. So, omega t minus omega t is equal to 0. So, there is no phase difference. Now, we plot the graph of voltage versus current. If you plot the graph, graph is very simple. It is T, it is V, and in all the discussion, first of all we plot the graph of voltage, because from the voltage we get current. So, first of all we start with voltage, then we get the current. So, therefore, first of all you plot the graph of voltage. It is a common method. So, first of all we mark the voltage, and I said how to mark the voltage by continuous line, okay, solid line like this, plus V naught, this is T by 4, T by 2 minus V naught, 3T by 4. Okay. Then we plot the current. Current also varies with the same phase angle as that of voltage. Therefore, the graph of current is like this. It is the graph of current, it is the graph of voltage, and here we are plotting both of them. Therefore, we will write like this. In x axis you have to mention it, it is V and I together. So, this is the graphical representation of current and voltage. Next step, I want to explain about phasor diagram. So, very important, phasor diagram. So, what is the phasor diagram for resistor circuit? First of all, we try to understand what is the phasor diagram. Phasor diagram means we know voltage and current, both of them are scalar quantities. Voltage is a scalar and current is also scalar quantity. But in this topic they are taken as rotating vectors because they got a phase angle. Therefore, voltage and current, even though they are scalar quantities, they are taken as a rotating vectors. Then that diagram is known as phasor diagram. And to this phasor diagram, we can apply all the rules of vector diagram. Now, how to mark it? How to represent voltage as a vector? It is a scalar, but here it is taken as a vector. Current is a scalar, but here we take it as a rotating vector. How? Now, amplitude of voltage is taken as a vector V naught. See, V naught is taken as a vector and it is rotated in which direction? Anti-clockwise direction. And this angle is the phase angle omega t. It is taken as a phase angle omega t. As the time increases omega t, that angle also increases, and this vector is rotated in the anti-clockwise direction according to the angle. Angle depends upon time. And if its y component, if you take y component represents instantaneous value. Y component of this represents instantaneous value. See, it is omega t. Therefore, what is the component here? It is nothing but V naught sin omega t. And what is the component in this direction? Cos function. Because omega t, here it is a cos function, for y axis sine function V naught sin omega t. What is V naught sin omega t? It is nothing but V, instantaneous value. Therefore, in the phasor diagram, as the time changes, this angle changes. As this angle changes, this vector V naught vector rotated in the anti-clockwise direction, and its y component gives the instantaneous value. Okay. Now, I want to represent current. How to represent current? Again, same logic. If V naught is taken as a vector, for the current I naught is taken as a vector. I think that both have the same phase angle in this case. In the case of resistor, see, both have the same phase angle. Therefore, even for current, phase angle will be same, and this is I naught. As V naught rotates, even I naught also rotates. So, we take its component. If you take the component along y axis, then this is the component of current, and it is nothing but I naught sin omega t. But what is I naught sin omega t? Instantaneous value. Therefore, I is equal to I naught sin omega t, that represents instantaneous current, and this represents voltage. This is phasor diagram for voltage and current. Both have the same phase angle. They always rotate together. Means, think that voltage makes 90 degree, then current also makes 90 degree. If voltage makes 120 degree, even I naught, that also rotates by 120 degree. If voltage completes one rotation, V naught, 360 degree, even I naught also completes one rotation. So, throughout they are together. Therefore, we say V and I are in phase. V and I, voltage and current are in phase. Okay. Now, we have got some other cases where voltage and current need not be in phase. So, in the next discussion it comes like that, voltage and current, they have got a different phase angle. Then how to explain? So, let us say it is voltage V naught, and current is like this. They have got a different phase angle. Now, angle is always measured from x axis in the anti-clockwise direction, remember, anti-clockwise direction. So, it is very clear. If you measure the angle, angle for voltage is more and angle for current is less. To make it clear, let us say this angle is 40 degree, think that 40 degree, and this angle is just 30 degree. Now, tell me which one is having the larger phase angle? Definitely voltage. Voltage is having the angle of 40 degree and current is having smaller angle 30 degree. Now, they are out of phase, remember, they have got a different phase angles, they are not in phase, they are out of phase, and the quantity which is having higher phase angle, we say it is leading. So, what is the meaning of that? In this case, in this graph, V leads I. By how much? V leads I, because voltage has got a higher phase angle 40 degree, current has got a smaller phase angle 30 degree. What is the difference? Is it not 10 degree? So, we can say like this, V leads I by 10 degree, or you can express that one in radian also, but to make it simple I am writing in degree, it may be radian. Okay. Can we explain this one in another way? Yes. Now, before discussing that, I want to take one more case. Let us say two students, they participate in a race, 100-meter race in a college annual sports meet. Two students, let us say it is the starting point, it is the finishing point. Start and finish, let us say 100-meter race. Two students, they have participated. Let us say one of them, to make it simple, we say X and another student Y. So, both of them are running like this. Let us say it is the student X, here is the student Y. Both of them are running towards the finish point. And as they run, let us say X is running little bit fast, Y is running slowly, so that the distance between them, let us say it is 2 meter, gap between them is 2 meter. Now, how to explain this? Very simple, if you look into this case, immediately you will tell both of them are running, both of them are participated in the running race competition, such that X is leading by how much? 2 meter with respect to Y. X is leading by 2 meter with respect to Y. What is the another way to explain? Another way is to explain that Y lagging behind X by how much? 2 meter. So, Y lags by how much? 2 meter with respect to Y. Both of them are same, no? You are explaining the same thing. We can say X is leading by 2 meter or Y is lagging by 2 meter. Both same. Same type here also. If you look from here, we say voltage leads the current. But what is the another way of telling? Another way of telling or explaining is that I lags V by how much? 10 degrees. Both of them are giving the same idea. So, higher the phase angle leading, smaller the phase angle, that quantity is lagging. Okay. Now, we take one more case. I naught, it is V naught. Let us say it is 70 degree and it is 40 degree. So, what is the difference between them? Difference is 30 degree. Now, tell me who is leading? I is leading V by how much? 30 degree. So, I leads V by 30 degree or pi by 6 radian. Or what is the another way to explain? Another way is to explain that V lags I by 30. So, both of them are giving same idea. Okay. This is Phasor diagram, nothing but rotating vectors where scalar quantity is represented as vector quantities, and in that vector quantity amplitude is taken as a magnitude of. Now, how to correlate graph and Phasor diagram for resistance? Okay. So, first of all you plot graph of voltage followed by graph of current minus V naught, and here it is minus I naught. Here V and I. So, whenever you are, if you are asked to draw graph in exam, you have to mention what is taken along x axis and y axis, other you are losing the mark. Okay. Now, I want to plot Phasor diagram related to this. This is the graphical representation, and I want to now mark Phasor diagram. So, the method is like this: you extend this one, okay. Now, look here, it represents voltage V naught. So, this much length. So, I am taking this length as a magnitude of the vector. So, we mark V naught. We take it as V naught. Then this is omega t. We find out value of y component. That value of y component is V is equal to V naught sin omega t, instantaneous value, and take this instantaneous value to this graphical representation. So, draw horizontal line, and then this is V, instantaneous value. Now, I want to represent current also. So, it is a Phasor drawing. What is the magnitude? Magnitude is nothing but I naught. So, you take this as I naught, just measure it roughly, take it to this drawing. So, this is now I naught. And find out its y component. That y component is I is equal to I naught sin omega t, and this instantaneous value is taken to the graph. This is I. So, it is graphical representation, it is Phasor drawing. In this Phasor drawing, we have got both V and I, that both V and I are represented in this graph, and as time changes, both V and I are also changing. So, it is the way to link graph and Phasor diagram. And in exam, now itself I am giving one important point. In exam, if you can't correlate both, it is not necessary to draw both of them like this. You can draw that one separate, this one separate. So, no need of linking both of them. You try to link, if you if you can link, okay, draw it. Otherwise, you can draw them separately. Sometimes it takes a lot of time also to link both of them.